Alright guys, so we've already talked about acids and bases. Mrs. Vaught gave us some characteristics of just general acids versus bases. I can talk today. And now we're going to fine-tune that a little bit more and break them up into strong and weak.
You know, I kind of remember that a little bit when we talked about solutions. I think we had kind of briefly mentioned acids and bases. There's something to do with dissociating, I think.
Yes,
maybe.
You're right. Okay, so you should have a foldable in front of you, and we're in the inside of our foldable. So it should all be blank, kind of like what you see on our screen, or your screen. And we are going to start in the far top left-hand side with weak acids. And we're just going to give you some details about it, and then some characteristics. So your first detail is that we said in the past that you want to look for an acid. It's going to just start with a what letter?
It has to start with H.
All right, so we're just going to look for an H plus with an anion.
And so the anion is the negative part,
Yeah.
right? Because we're making ions. That's why they're electrolytes.
Mm-hmm. Remember, so we could say it's a negative ion for we to remember the difference between a cation and an anion. All right, so that's our first big punchline. The second thing is, because we want to know what's a strong acid and what's a weak acid, and we're going to give you a list of what the strong acids are. So a weak acid is going to be all of your other acids that aren't included in your strong acid list. Now, I put SA, we're not talking about San Antonio. I'm just going to abbreviate and put S for strong, A for acid.
All right.
Okay. So, some characteristics of a weak acid is going to be, first of all, that they only partially dissociate. Do you remember what dissociate means?
Ooh, I was just wondering about that. Dissociate. Does that have something to do with there's something splitting apart?
Yeah.
Right? They're coming apart?
So they only partially come apart. That's all that is.
Okay.
So do you think we should write coming apart underneath there?
Yeah, let's do that.
Okay. Come apart or pull apart? I'll say. Alright, the next thing that you need to know about a weak acid is that it's a weak electrolyte. Do you remember what an electrolyte is?
Those are the solutions that have ions in them so they can conduct electricity.
Yep.
Okay.
So it can't conduct electricity very well.
So okay, but it still will.
Still will.
Right? Okay.
Mm-hmm.
Okay.
Now, last little punchline, just in case you're having trouble with the pH scale,
Oh yes.
is we want to kind of give a number on the pH scale range of what a weak acid will be. And your pH is going to be close to but less than 7.
So it has to be less than 7 because it's an acid.
Mm-hmm.
Okay.
Okay. And remember, the closer you're getting to 7, the weaker the acid. And then just the opposite, if we go the other direction, the closer we're getting to that, because we said the pH scale ranges from 0 to 14.
Mm-hmm.
Closer to 0, the stronger your acid.
Okay.
Okay. So now we're going to work our way across, and we are going to put in the characteristics for our strong acid. So our first one is, if a weak acid only partially disassociates, what do you think a strong acid is going to do?
It's going to completely dissociate.
Completely dissociate.
So that means everything is going to dissociate, not just some of them?
Everything will completely break apart. So if you wanted an example of that, we could say, so just a little, if I had HCl and it were to completely disassociate to break apart, then it would break up into my H ions and my Cl ions. So we had a cation and our anions, breaking apart into their charges. Now, since a weak electrolyte, weak acids are weak electrolytes, what do you think a strong acid would be?
It's strong.
All right. I don't know why I put a capital G there. Okay. And the closer we just talked about, the pH is
So it's still less than 7,
less
but
than
it's
7.
going to be the other side, so it's going to be close to 0, like
So-
you were saying.
Mhm.
Okay.
All right, so now strong acids. We said for the weak acids, it's anything that's not a strong acid. Well, we're going to list off the strong acids that you should know. So the first one being H2SO4. You remember how to name H2SO4?
Sulfuric. Because it's not binary, so it's not hydro.
Yeah.
And then it's sulfate, so it's got to be ick,
Yep.
not us. Right?
Yep.
Okay.
All right. We've got HCl. You remember the name of HCl?
HCl is hydrochloric acid.
Hydrochloric acid. We have HNO3.
NO3 is nitric. It's nitric acid.
Yep. HBr.
Hydrobromic acid.
HI.
Hydroiodic.
I like the name of
That
that
one's fun to
acid.
say.
I don't know why. And then finally I have HClO4.
Oh, it is chloric acid?
I believe so.
I think so. Okay. We'll have to
Alright.
ask this couple.
She just knows everything.
So this is our list. Those are strong acids, and if we have anything else besides those,
It's
they're
considered
weak.
weak.
Okay, that's easy.
Pretty easy. All right, so we're gonna pick up the pace now that we kind of get the gist of what's going. A weak base. Now, usually we say the bases end with an
OH.
OH, but there is that one exception. And do you remember? Most of us forget the name of NH3.
Ammonia.
Oh, you're good.
This is so like the stuff that we use to clean the floor,
Yeah.
kind of.
And if you remember, you might have seen it in your lab for your acid-base lab. Okay. So this is kind of a little lengthy thing for how do you know if it's a weak base. It's going to be all the other bases that the cation. Do you remember what part of the cation is?
The
First
cat
part or
is
last part?
it's the first part.
First part, okay.
So it's the plus.
So it's the first part of your compound. It does not come from groups 1 or 2. Okay, so if the first part of your base, blah blah blah, OH, does not come from groups 1 or 2, then it's
weak. Okay.
Okay. So this is going to have similar characteristics. Actually, it's going to have the exact same characteristics as a weak acid. So we're going to say that it's only going to partially dissociate again. We will say that it is also a weak electrolyte. And then it's going to slightly change for our last main bullet, because our pH can't be less than 7 on this.
That's right. So it's going to have to be greater than 7,
Yeah.
but close.
So it's going to be close to, but greater
Okay.
than 7. Okay. Not too bad. Whoops, sorry, got off the page. So you might want to pause it a little bit in case I wasn't paying attention and chopped off the writing for you. You need to get it down. Right, now we'll slide over to the characteristics for a strong base.
So I bet these are probably going to be similar to the strong acids, aren't they?
You're awesome. So our first one is that it's going to dissociate completely. I can't spell at all.
So again, that we're saying that the pieces or the molecules are going to completely come apart. All of them are going to come apart. Okay.
And again, like the acid, a strong acid is a strong electrolyte, so same thing for a base. It's a strong electrolyte if it is a strong base. And then last but not least, again, this is going to be the exact opposite end of our pH scale. So we want the stronger the base, the closer it is to
14, because that's, yeah. Okay, awesome.
Okay, so since we're not going to list every single strong base that comes from group 1 or group 2, we're going to just give you a brief little list. But again, remember that your cation comes from groups 1 or 2 for it to be a strong base.
So as long as that metal is in group 1 or group 2, we can call it a strong base.
Yep.
Okay.
So our first one would be LiOH. So if you look at Li, what group is he in?
Li is in group 1.
And he has
so
a
that would
OH to
make
its
it,
base. And then I've got NaOH, another one from group 1, KOH,
Still going down.
CaOH with a 2.
That one's in group 2, so we're also good.
Yep. Then I have SrOH with a 2. And then BaOH with a 2.
So as long as it's just any of those from group 1 or 2.
Yep.
Okay.
And so, for those of you who want to leave this open, it's perfectly fine to leave it open. For those of you who kind of like to have it folded, if you notice on the flip side of your paper, you should see this right here. So, you should see all of these things on the flip side of your paper. So we're going to make it this handy dandy foldable. And again, this is only for the people who want to fold it. If you want to leave this wide open, it's perfectly fine. You're going to fold it in towards the middle on this side, and then fold it in towards the middle from the opposite side. And
little flaps for us.
you can cut it on these lines right here, so that way, ideally, when I open it, and look, we'll rip it, so that when I open it, all I see is stuff about a weak acid. Then when I open this one, all I see is stuff about a weak base, and vice versa. But your call, fold it, leave it open, do as you wish.
That was nice and easy.
Yes, it was.
I guess at this point we can go work on our practice or kind of keep trucking through the material.
Yep.
Alrighty, sounds good.
See you later.